Okay, so welcome back, and we carry forward where I last week left you all, which is to deal with logic based agents which make in their decision based on some kind of logical rules and facts. And of course, last week I cheated too many times by nicely selecting rules because there were just too many of them. Now, the problem is that even though there were many rules, programs would use automated means to really do an inference, but I, as a person designing the system, had to really write down the rules like studies AI R1 and studies and bad marks in AI for the student R1 implies honest in AI R1, and I had to do it for R2, R3, all the row numbers. And you know that this course is not taken by three people, it's taken by an endless number of people. So I literally have to type it for each and every student, and that's absolutely bad. And that's one of the major limiting factors of what we studied last week. Another thing would be that my queries were simply the last week, hey AI agent, tell me R2 is honest or not, and it said that nope, R2 is not honest. Why cannot I do something else? Why cannot I tell my AI agent that, hey, I got a call, somebody cheated out of all these students, you find out who it is, and I get a list of all the students who cheated, and I could take an action on them as said by AI, not me. So, these are the things that we'll try to mend in, and in order to do that I'll have to uplift all the concept by one more level, and after I uplift them by one more level it will be called as the first order logic, and correspondingly what we studied previously would henceforth be called as the zeroth order logic. Something before one, it is what is zero. So let's get started. And first order logic, I'll completely informally cover it up, telling you only the short and sweet definitions. The agenda would also be to look into Prolog and do some real programming. So I'll be covering whatever you'll need for that. First order logic is different from the zeroth order logic because we do not talk about or studies AI R1, which could take in true or false, but we study about objects. Similar to object oriented programming, the objects are entities. If you're doing a real world implementation, there would be physical entities with physical properties like instructor, calls, everything in object oriented programming you would have made classes and objects of. The students will number 1 R1, calls say I, and the objects are related to each other by we call as relations. So again, an object-oriented reference. So R1 is a student of AI, and M is the marks of the student of AI scored by R1, and different objects are hence related to each other. So, first order logic, we are actually talking about some object which is R1, R2, R3, a course which is AI, all of them objects, a person who is, of course, RK, and they are related to each other, like R1 is a student of AI. AI is a course taken by R1. We will model it as the relation studies R1, the course AI, and similarly studies R2 AI. So AI and R1, R2, R3 are related by this relation that they are studying this course. RK and AI are related because one is the instructor of the other. So RK is the instructor of the course AI. R2 and R3 are also related to each other. They are friends. Let's say R1 and R2 are also related to each other. They are best friends. And please make sure that they are directed arrows. So I will have to say the converse also holds good. R3 is also friends with R2. However, to be honest, R1 is the best friend for R2, but the inverse may not be true. R2 may not really be the best friend of R1. R2 may have another best friend, which is, let us say, R3. So I may have the best friend of R2 is actually R3, and so on and so forth. So this nice relation that you see out over here, multiple objects, they are somehow related to each other, is what defines the first order logic. So now there are two things. Number one, they are objects and their relations like this. And the second thing is some relations may hold good, some may not hold good. The relations themselves may be true, all the relationships themselves, all the relations themselves may be false. Like the relation friends R2, R3 is true. However, friends R1, R3 is false. They don't have a friendship relation between each other. I'm not sure what love story was I imagining that just evolved just because R2 is a best friend of R1. However, R2 actually loves R3. Somehow R1 and R3 now are not in good talking terms. They're not friends. Completely hypothetical. So, we're dealing with this kind of a logic. Now, I talked about relations. We'll talk about another interesting term, which is a function. And of course, if you look at this one pretty carefully, whatever you know in life, but unfortunately, best can only be one, otherwise, it's not really best. So if R2 is the best friend of R1, then unfortunately there cannot be any best friends more. There is only one best friend in a hypothetical example. No offense to you people. So when this will be only true for R2, I can more conveniently write it down in a slightly more convenient fashion, which means R2 is the best friend of R1 and similarly R3 is the best friend of R2, and these are what are functions. So the mapping is one on one, And because the mapping is one-on-one, I just say R2 is equal to best friend of R1 and R3 is the best friend of R2. When we talk about relations and functions, of course, we do talk about an arity. So arity is just a number of arguments that it takes, like male R1 is the roll number R1 male, it just takes an arity of 1. Friends R1, R2, it takes in 2 arguments, the arity becomes 2. So this is unary, this is binary, and similarly you may have things which take in 3 arguments like studies. Roll number R1 studies AI in the section A batch. There are some students who can recite sections on their own. They may study AI in one section and machine learning in the other section. Perfectly okay for that. So that's what's called as a arity. Now, what we have is that when we talk about these things, this specific diagram and the relations and the functions have a special term. It's called as the ontological commitment, which is what is the commitment that the different objects they share to each other, and that's the only thing that I'll be teaching you. There are a lot of things that I'll not be teaching you. So what is not into the curriculum is the temporal logic. I love this one. So here the relations they change with time. So you were friends only based on certain condition which changes along with time. You friends till the assessment. After the assessment you become enemies. Thereafter you become friends again. And all that is based on some logical conditions, temporal logic. We won't be studying that. They're higher order logic. So the higher order logic is nothing but when you define relations of the first order logic themselves as objects. So that's you move one step higher. You state how do the relations relate to each other. Like some relations, they may have certain properties, commutativity, associativity, whatever. So you define in relations on the first order relations, treating the first order relationship as the objects themselves. There are also what we won't be talking about, the epistemological, I hope I can spell it correct, epistemological commitments. I won't be teaching you, but somebody else will be in later in the career. So then we say about, I do not know whether role number 1 and role number 2 are friends or not. 30% they are friends, 70% they are not friends. Or you say that 20% I know they are friends, 10% they are not friends, 70% I do not know. That's a complete uncertain gray region for me. The probability that they are friends is 0.25, or the degree of by which they are friends is 0.3. Fuzzy logic is exactly what you will be studying, and then there are some uncertainty theories that you'll specifically be studying in another course, not this semester. So that's what we will be not talking about. There are also some assumptions that we will be making, and I need to tell them. Firstly, all relations are actually tuples. So if you say R1, R2, best friend, whatever, it's not equivalent to R2, R1. The order matters. So best friends R1, R2 does not mean best friends R2, R1. Studies AI, comma R1 is not equal to studies R1, comma AI. But what's more surprising is that we will deal with what is called as the total functions. So that means for every possible input, you need to have an output, and that may actually be weird. And what I tell you next might become the thing of the entire course that really buggles you up. So let's take a simple example first. So I had something like studies AI, comma R1, studies ML, comma R1, they are true. Studies robotics R1 is not true, it's not being offered, no offense to the student. However, what about studies AI ML? Of course, it's not true, but it does not even qualify. The second argument was a roll number. In C, it would have been a segmentation fault. In C++ Java, it would have been a segmentation fault. AI object is an object. It does not have a type. And because studies takes two arguments, if I give it ML as second completely baseless, irrelevant argument, my AI engine doesn't know the second argument is irrelevant. For it, ML is another course and it's same as any other object. Trees, mangoes, roll number R1, or triple IT Allahabad, or whatever. It's same as everything else. There's no type of the object. So even if I pass a wrong object by common sense, my AI will not have this common sense. Everything is an object, so it needs to have a false. Similarly, you could have in friends R3 comma AI. Is R3 friends with AI? It doesn't make any sense. Normally over here you do not do friendship with courses, but you need a true or a false. So a false has to be explicitly known. So that's one of the weird things that we will unfortunately have to deal with, and it will change the way that I do in algorithmics. The other fact which again is important is not all objects may really have a name. There may be objects which do not have a name. Studies best friend of R3. Now remember, we talked about best friends of R1, we talked about best friends of R2. I do not know who's the best friend of R3. It could be R1, it could be R2, it could be a roll number which I do not even know of. I may not always tell my AI engine about all the objects. However, I know that the best friend of R3 studies AI. It may or may not be R1. I also can say the best friend of R3 studies AI. I could also say in friends, the best friend of R1 with the instructor of robotics. Who teaches robotics? I did not tell you. Of course, using common sense, you could make out, but I didn't tell you that. Unnamed object. Who is the best friend of R3? I did not tell you. And similarly, R3's best friend, let's say R10. R10's best friend, I did not tell you. So, AI unfortunately will have to take care of all these issues as well. Not all the objects may have name. You may not know about all existing objects. The roll number or the roll list may not have been specified. And many of the objects may really not have a name. And of course, that's because of the existence of the functions that makes this thing absolutely interesting. So now let's quickly go into, and I'll just tell you about the major concepts which are there in the first order logic, light agenda. So let's write down something which is a first order logic. You already know about the objects, you know about the relation. So this is what is a relation between two objects. This relationship between two objects is also what is a predicate symbol. Predicate because it's true or a false. Symbol because of course it is a symbol, and predicate because this relation may hold good or it may actually not hold good, and every relation will have a arity, like this is binary, which means an arity of 2. Always do remember that the bottom line of the entire course will be that the number of objects are unknown, which means they could be infinite. So best friend of 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 R3. And I was really very narrow-minded by that. I only give you one function which is best friend. Otherwise, the mother or father of best friend of best friend of daughter of whatever, you could complexify the relation to as many times and as many values as you want. And because the number of objects could be infinite, this is what we actually say is the real problem of the first order logic. So this is, let's say, R1, this is, say, R2. So this is R1, so this is an object and it is actually given a name which is R1. Now it will sound like Java. This is R2, it's actually given a name R2. And R1 and R2, the objects, they do share in a relationship of best friend, also a friend. There is another object which is best friend of R2. However, best friend of R2 is not given a name. There is a best friend of R2 that's not given a name. There is a calls AI, and luckily that is given a name. So this is what you see when programming. You only have your named objects, and this is what the inference will operate upon, and mapping this to this is what is called as an interpretation. Which object does R1 really refer to and which object does R2 really refer to? Sometimes many objects may have exactly the same name. So let us say this is the course AI, and what I also have is that I refer to exactly the same course by the name C previously. So that's a problem that I actually need to solve, that I say who cheated, and AI answers me that this guy cheated, and the name of this guy is best friend of R2. So I could ask AI questions like this, and it still needs to be able to answer it. That's what we call as the interpretation problem, and that's what is for my AI engine to really solve.